Imagine a point on a wheel that is rolling without slipping along a road. That point traces at a path that we call a cycloid. You can see this in the image here. The cycloid generated with circle of radius a can be described with parametric equations. We have x of t equals a times the quantity t minus sine t, and y of t equals a times the quantity 1 minus cosine t. We can easily graph cycloid functions. It is also easy to determine the equations of a cycloid by looking at its graph. Take this graph for example. What equations produce this graph? First, we notice that the cycloid cycle repeats every 10 pi units. This happens at one revolution of the circle that created the cycloid, which is at t equals 2 pi. We start with the general form equation for x. X of t equals a times t minus sine t. Substitute 2 pi for t. Since x of 2 pi equals 10 pi, we can simplify to get 10 pi equals a times 2 pi minus 0. Solving for a, we get that a equals 5. Notice that this agrees with the height of the curve. The curve has height of 10, which should be the diameter of the circle that traced this cycloid. Therefore, the radius is 5. Next, we need the limits on t. Notice that the left edge stops at y of t equals 10. The right edge is at 10 pi, 0. Let's use the equation for y to solve for t. Since a equals 5, we have y of t equals 5 times 1 minus cosine t. We will substitute 10 for y of t, which allows us to solve for t. We get that cosine of t equals negative 1. So, the value for t that best fits this graph would be t equals negative pi. Finally, the full equations are x of t equals 5 times t minus sine t, y of t equals 5 times 1 minus cosine t, for t from negative pi to 2 pi.